Hi dear students, welcome to Mandawad Maths Academy. Today we are going to start the linear algebra and calculus engineering first year mathematics. Okay, the first chapter is matrices. So do you know we already studied about the matrix. So what is a matrix? Matrix is nothing but the number of elements that can be arranged in the m number of rows and n number of columns in a rectangular array. So that is called as matrix. So generally matrix is denoted by capital letters, capital A, capital B, capital C and so on. The elements of matrix are denoted by small aij or the small letters. The small aij indicates I indicates ith row and j indicates jth column. Okay. Suppose for example, the matrix A, I take 1, 2, 3, 4, 5, 6, 7, 8, 9. So how many rows? These horizontal numbers are called as rows. Yes, this is the first row, it is denoted by R1, this is R2 and this is R3. This is called column number 1, column number 2 and column number 3. Means C1, C2, C3, R1, R2, R3. So how many elements in this? 9 elements can be arranged in a such a way that m number of rows and n number of columns. This m indicates number of rows. What? Number of rows, and n indicates number of columns. So this order of this matrix A is m by n. The matrix or the matrices are classified in this ways. Types of matrices, first one is row matrix. Row matrix having only one row. You can remember column matrix having only one column. You can remember here, you can write only one row and only one column. It has only one row and it has only one column. Suppose for example, A equal to 2, don't write comma, 2, 3, suppose 4. How many rows in this? Only one row, R1. How many columns? 3, 1, 2, 3. Means the order of this matrix is 1 by 3. One column is nothing but you can write this as 2, 3, 4. How many columns in this? Only one column and rows are 3, 1, 2, 3. So therefore, this matrix is called as column matrix. What is the order of matrix? Order of matrix is nothing but 3 into 1, or sorry, 3 by 1. Always you can remember, you can write first number of rows, then number of columns. So what is meant by square matrix? Square matrix is nothing but number of rows is equals to number of columns. Means m is equals to n. M is nothing but number of rows and n is equals to number of columns. Suppose for example, A equal to 2, 3, 4, 5. So how many elements in this? 4 elements that can be arranged in 2 rows and 2 columns. Here m value 2, n value 2. So that is called as square matrix. Rectangular matrix is nothing but number of rows not equal to number of columns. Means m is not equal to n. Suppose for example, 2, 3, 4, 1, 2, 5. How many columns? 1, 2, 3. 3 columns and 2 rows. Means 2 by 3 is the order of this matrix. What is meant by diagonal matrix? You can remember the diagonal matrix is nothing but a square matrix in which the square matrix is nothing but m equal to n. Means we need to define diagonal matrix. So first that matrix should be square matrix. Okay, the square matrix in which all non-diagonal elements, can remember condition, all non-diagonal elements, all non-diagonal elements, all non-diagonal elements equal to 0. What is meant by non-diagonal elements? So diagonal, except the diagonal elements, the remaining all elements are called as non-diagonal elements. Suppose for example, so these entries are called as diagonal elements, yes. So remaining are non-diagonal, means below the diagonal elements, above the diagonal elements are 0 except these diagonal elements. Diagonal elements may be 0, may not be 0. Suppose I take here 1, 2, 3. Below the diagonal elements all 0 and above the diagonal elements are 0. So that matrix is called as diagonal matrix. Means diagonal matrix having non-diagonal entries are 0. All non-diagonal elements are equal to 0. So that matrix is called diagonal elements. The diagonal elements is nothing but a square matrix in which, means this matrix should be square matrix. Then we can define non-diagonal elements. Square matrix is nothing but number of rows is equals to number of columns, means 3 by 3. Next, what is scalar matrix? In this diagonal matrix, this all diagonal elements are same. So that is called as scalar matrix. Scalar matrix is nothing but diagonal matrix in which all non-diagonal elements are 0 and diagonal elements are same. What? Diagonal elements are same. Means we take any number but the diagonal elements are same. Suppose for example, we take 2, 2, 2. These are the diagonal elements. We take these diagonal elements are same and non-diagonal elements are 0. So that matrix is called as scalar matrix. Is it clear? So first square matrix, number of rows is equals to number of columns. Then diagonal matrix. Diagonal matrix is nothing but a square matrix in which all non-diagonal elements are 0. For example, this scalar matrix is nothing but diagonal elements are same. Diagonal elements are same and non-diagonal elements are 0. What about identity matrix? Identity matrix is generally denoted by I. A scalar matrix in which all the diagonal elements are 1. All diagonal elements are 1, non-diagonal elements are 0. So that is called as identity matrix. Suppose the order of matrix is 3 by 3, so you can write here I3. Order of matrix is 2 by 2, then you can write here I2. Order of matrix is n by n, then you can write here IN. Is it clear? Yes, very good. Next, null matrix is nothing but the matrix having all entries are 0. Means the matrix in which all entries are 0. So that matrix is called null matrix or 0 matrix. Is it clear? So once again I repeating this. Row matrix has only one row. Column matrix only one column. Square matrix m equal to n. Rectangle matrix m is not equal to n. Diagonal matrix all non-diagonal elements are 0. Diagonal elements we take any number. Next, scalar matrix all diagonal elements are same. This is very important and non-diagonal elements are 0. For example, this 2, 2, 2. So these diagonal elements are same, non-diagonal elements are 0. Identity matrix. What is identity matrix? The matrix in which all non-diagonal elements are 0 and diagonal elements are 1. So this is called as identity matrix. The null matrix is nothing but all entries are 0. Next, symmetric matrix. What is symmetric matrix? Suppose you can write A equal to A transpose. What is A transpose? A transpose is nothing but interchange the number of rows and columns. So that is A transpose. A equal to A transpose. So that is symmetric matrix. What about skew-symmetric matrix? A equal to minus A transpose. So this is a skew-symmetric matrix. You can remember only these two conditions. If A equal to A transpose, that is symmetric matrix. A equal to minus A transpose, that is skew-symmetric matrix. Okay. So next type of matrix is upper triangular matrix. What is upper triangular matrix? The matrix in which, a square matrix in which, so these are called as what? Principal diagonal elements. Principal diagonal elements. The upper triangular matrix is nothing but a square matrix in which all the below the diagonal elements, all below the diagonal elements are 0. So that is called as upper triangular matrix. Same, what is lower triangular matrix? A square matrix in which all the above the diagonal elements are 0. So that is called as a lower triangular matrix. Suppose for example, let us consider A 1, 2, 3, suppose 9, 3, 6. So these elements are lower, so below the diagonal elements. What? Below the diagonal elements. Here to form a figure like that triangle. Okay. So this is upper triangular matrix. Next, lower triangular matrix is nothing but above the diagonal elements are 0. Above the diagonal elements are 0. So that is called as lower triangular matrix. So this is lower triangular matrix and this is upper triangular matrix. So next one, singular matrix. So we know determinant of matrix is nothing but you can find the value of determinant. Determinant is 0. Determinant of A equal to 0. So that A is called as singular matrix. Non-singular matrix is nothing but determinant of A is not equal to 0. So that is called as, that A is called as non-singular matrix. Singular means determinant is 0, non-singular means determinant is not equal to 0. So these two are the very important. Orthogonal matrix. What is orthogonal matrix? A into A transpose equal to A transpose into A equal to I. What is I? I is called identity element, so identity matrix. So this is called as orthogonal matrix. Suppose for example, we take any example, suppose 1, 2, 3, 4. What is this? This is A. Means A transpose is nothing but 1, 3, 2, 4. Means we interchange the rows and columns. So that is called transpose. If we take the product of A into A transpose, we get I. So that time that A is called as orthogonal matrix. Is it clear? Next, unitary matrix. What is unitary matrix? A into A power theta equal to A power theta into A equal to I. What is this A power theta? So that is called as, A power theta is nothing but conjugate transpose of A. Suppose for example, A theta, how to find A theta? Suppose A equal to 1, 2 plus 3i into 3. Suppose this is A. What is A theta? A theta is nothing but, first we take this conjugate. What is conjugate of this? Conjugate, that is nothing but A bar. Okay. This A theta can be defined as A transpose, A conjugate transpose, or you can take conjugate transpose of A. First we take conjugate of this. Conjugate is nothing but, if in this matrix having complex numbers, so we can take conjugate of that complex number. Means 1, 2 plus 3i conjugate, 2 minus 3i, 2 as it is, 3 as it is. So we take conjugate of transpose of this. So what is the transpose of this? Interchanging rows and columns. Means 1, 2 minus 3i, here 2, 3. So this is A theta. Is it clear? If we get A into A theta I, so that is called as unitary matrix. What? Unitary matrix. Is it clear? Upper triangular matrix is nothing but below the diagonal elements are 0. So that is called as upper triangular matrix. Lower triangular matrix, above the diagonal elements, all elements are there 0. So that is called as lower triangular matrix. Singular matrix, determinant of that A is equals to 0. Non-singular, determinant of A not equal to 0. Orthogonal matrix A into A transpose equal to A transpose into A equal to I. What is I? I is called identity matrix. Unitary matrix is nothing but A into A power theta equal to A power theta into A equal to I. What is A power theta? You can remember, this is called as conjugate transpose of A. What is conjugate transpose of A? Given matrix having complex numbers, so we can take conjugate of that, then we take transpose. So whatever matrix is that, so that is called as A power theta. Is it clear?